So let's talk about each of them individually. So the first one, the fundamental theorem of gradients. So suppose we have a function t of x, y, and z. And suppose we start at point A and we move dl1, a small distance dl from point A. Does that mean that my function t will change by this amount? Where this is the dot product? Why dot product? Because it's going to require that we specify the angle between them. Okay. Now, what happens if you move further dl2? Will that be a small change in delta t? And will that small change be written like can this all continue until I reach point, say, B? So if I start at point A, I can make small changes until I reach point B. Is that true? Small, 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 small changes. Small DLs. Can I then sum over all of the DLs to then write my total expression as integration A to B del T dot DL? And can I further write this? And this is going to be dt, right? On this side. Can I further write this as TB minus TA equal integration A to B del T dot DL? Oh, sorry, DL should be vectors. Does that remind you of something? When I started, I called this the fundamental theorem in 1D. It's equation, let's call it A. All it is equation B is the fundamental theorem instead of in 1D, in 3D. That's all there is. So now physically, how can you interpret that? Well, think about it. What does this side say? Suppose I want to measure the height of the atrium outside where the pendulum is, going back to our independent thought days. How can I measure them? Well, one way to measure it would be to take all the steps one by one, measure the height of each step one by one, and then add all of them together, correct? That will give you the height of the atrium. Or what you could do is, you know, wear one of those fancy watches that have the altimeters, you know, the ones that tell you the height. So you can measure it down on the floor, then you can take it all the way up, measure it there. So which side do you think corresponds to that scenario? The left-hand side or the right-hand side? So this is my left-hand side, and this is my right-hand side. So if you notice very carefully, the left-hand side represents the values at ground and at top. And subtracting those two values just gives you the height. Whereas the right-hand side actually represents you taking each step up and then summing over all of those steps. You see how that works? So fundamentally, once you understand what these things are saying, you'll never forget it. So the right-hand side represents, how do I write this? Values measured at points A and B. Whereas the right-hand side represents small changes summed over in the end. Woo-hoo.